Alright, so now we are going to level up the difficulty. So as you can see, okay, in the previous question, everything was done on the x-axis, okay, on left and right. But now you are introducing it where there is an upward force as well. Okay, but the steps are still the same, and we are going to go through them one by one. Okay, so step one, okay, write the scale. So I'm just going to use the same scale again. So let 1 cm or let maybe 2 cm equals to 1 Newton. Okay, so step 2, I create a starting point. Okay, so I can create it anywhere because I'm going up, so I'm just going to start here. Okay, and then I'm going to draw one force arrow. So I'm just going to draw, so it's 4 Newtons, so I need to draw 8 cm. Okay, so that's straightforward. So I have my endpoint here. Okay, and then I'm going to draw my next force arrow. So where do I start drawing my next force arrow? Do I start drawing it from here? Okay, the starting point. Okay, maybe I just put a starting point as O, like for origin. Okay, or do I start it from the last point? So if you look at the previous example, okay, in a previous example, we started from where we ended off. So the principle is the same. You're going to start where we ended off, and we're going to draw 3 Newtons, so I'm going to draw 6 cm upwards. Okay, maybe I should have given a bit more space. So right here, this is my 6 cm point. Okay, it's not exactly 90 degrees, I didn't draw it that well. Okay, but by right, you should draw very precisely. Okay, and so after you have drawn the force arrows, okay, I've forgotten already. Okay, so remember what I told you all. It's important that you all have to draw the arrows, okay, as well as label the force. So down here 4 Newtons, and down here 3 Newtons. Okay, so we have already done step 1 to 4. So now we are at step 5. Okay, we have to measure the length of the resultant force. And how do we find the length of the resultant force? If we look, okay, at this example, we have a starting point now here, and this is our ending point. Okay, and so what we do is, okay, we measure from the starting point to the ending point. And the principle is once again the same. So we have our starting point here, and we have our ending point here. And so we are going to draw a line through from the starting to the ending point. Okay, and once you have drawn that, in order to show that it is the resultant force, what we do is we draw a double arrow. Okay, and then we will have to measure the length. And so the length is roughly 9.9 cm. Okay, do I write the 9.9 cm here? No, I don't. So I just put 9.9 cm here. Okay, and so I need to convert it back into Newtons again. Okay, so I have, let 2 cm equals to 1 Newton. So my 9.9 cm is around 4.5, 4 point something, okay, 4.95, I think, something around there. Okay, so I'll write my 4.95 over here. Okay, so the correct answer by right, it should be 5 Newtons because I mean you already know Pythagoras theorem, right? So down here I got a right angle, so if this is, okay, so a square plus b square equals to c square, right? Okay, so I have 4 square plus 3 square equals to x square, and then I'll realize that my x is equals to 5 lah. Okay, so it's close enough, okay, because I did not draw the angle accurately enough. Okay, as you can see, I missed it by a little bit down here. Okay, but by right, if you draw it accurately, you'll be able to get the correct answer. Okay, And so your correct answer now here will be by right 5 newtons lah, okay, but this is my answer that I've gotten, 4.95 newtons. Okay, and so this is an example of how we use the vector diagrams to solve questions.